Hello and a very good day to everyone. Today we will discuss about hydropower generation. So, what is hydropower generation? The use of falling or fast running water to generate energy or power machinery is known as hydropower, also known as water power. This is accomplished by transforming water sources, gravitational potential or kinetic energy into electrical energy. Hydropower is a form of renewable energy generation. Hydroelectric power plants are often built in dams that impound rivers, raising the water level behind the dam and creating as much head as possible. Because the potential power that may be derived from a volume of water is directly proportional to the working head, a high head installation requires a lesser volume of water to create the same amount of power as a low head installation. In a certain dam, the powerhouse is built on one side of the dam, with a portion of the dam serving as a spillway to dump excess water during the floods. The powerhouse may be positioned within the dam itself, where the river flows through a tight, steep valley. So, next, my friend will talk about history of hydropower.
History of hydropower generator. In 1878, the world's first hydroelectric project was used to power a single lamp in the Craigside Country House in Northumberland, England. By the turn of the century, the technology had spread all over the world, with Germany producing the first three-phase hydroelectric system in 1891. and Australia launching the first publicly owned plant in the Southern Hemisphere in 1895. The Edward Dean Adams Power Plant, the world's largest hydroelectric development at the time, was built at Niagara Falls in 1895. Hydropower became a viable source of electricity in the late 1800s. A few decades after British-American engineer James Francis invented the first practical water turbine along the Fox River in Appleton, Wisconsin. That is the world's first hydroelectric power station started functioning in 1882. That's it a little bit about the background and history of hydropower generator.
A large hydroelectric dam able to generate more than 30 megawatt of electricity. But how do we get electricity from water? The force of the flowing water from the reservoir travels down a steep pipe called penstock, pushing against the hydraulic turbine's blade, causes the turbine to spin. The hydraulic turbine converts the kinetic energy of flowing water into mechanical energy. Then, the hydraulic generator, which is connected to the turbine by the drive shaft, spins when the turbine spins. Hence, the generator converts the mechanical energy from the turbine into electricity. The electricity travels along high voltage wire to transformer, then onto the transmission tower where it connects to the power grid. The operation of a generator is based on a principle discovered by Faraday. He found out that when a magnet is moved past a conductor, it causes electricity to flow. In a large generator, electromagnets are made by circulating direct current through loops of wire woven around states of magnetic steel laminations. These are called field poles and are mounted on the perimeter of the rotor. The rotor is attached to the turbine shaft and rotates at a fixed speed. When the rotor turns, it causes the field poles of the electromagnets to move past the conductor mounted in the stator. This in turn causes electricity to flow and the voltage to develop at the generator output terminus. Next, we are going to proceed with the basic construction of the hydropower generations.
This is the basic construction of a hydroelectric power station. The power station consists of the dam, control gate, penstock, turbine, generator, and a powerhouse. The dam will create a large water reservoir for the power station. Then from the reservoir, the water will flow through the penstock that connect the reservoir to the turbine. The amount of the water that flows through the penstock will be controlled by the control gate here. And as the water flows and hit the turbine will be rotated. The generator are responsible to convert the mechanical energy from the rotating turbine to electrical energy. Lastly, the powerhouse that contains transformer in it will transmit the power to the consumer via power lines.
The example of hydroelectric power plant is the Three Gorges Dam located at the Yangtze River, China. It is 2,335 meters long with a maximum height of 185 meters. The power plant has 34 turbine generators and generates 22,500 megawatt of electricity, making it the most productive hydroelectric dam in the world. The dam is also intended to protect millions of people from periodic flooding. The drawback of the Three Gorges Dam is it causes the displacement of 1.3 million people, destruction of countless archaeological sites, wildlife, and rare architectural.
The second example of hydroelectric power plant is the Itaipu Dam, which is located in between Brazil and Paraguay. This dam is the second most electricity producing hydroelectric power plant in the world, which is only to surpassed by the Three Gorges Dam. The total capacity of this dam is 14 gigawatt. With hydraulic design height of 180 meters, which is 387 feet, it has a total of 20 power generating units providing 700 megawatt each. Among these 20 units, 10 units generates power for Brazil, while the other 10 generates power for Paraguay. Among these 20 generating units, only 18 are usually used and 2 are used for reservation purpose. Around 40,000 people worked on this dam construction. The construction of this dam came with a price which was 10,000 families were had to relocate.
And finally, we have come to an end of our video about hydroelectric power. This is the reference we use from 1 to 7 link. And lastly, this is our group member profile and names. That's all for our video today, and thank you.